Alright friends, we are now ready to start off our first chapter, that is real numbers. The first thing that we are going to look at is Euclid's division lemma. Now what do you mean by a lemma? A lemma is a small proven theorem that is used to prove other big theorems. Now what does that mean? It means that as we progress through this course, we will be using Euclid's division lemma frequently to prove other theorems in this chapter. So let's clearly understand what Euclid's division lemma is. To understand Euclid's division lemma, let's first try to look at some of the simple examples. Now let's try to answer this question. This is very simple, so hold on until we get to Euclid's division lemma. Now what is 23 by 7? When I divide 23 by 7, I get the result as 3 and 2 by 7, right? In other words, I can express 23 as 7 times 3 plus 2. Now this is something that we have already learned in our previous grades. Now what if I change the divisor to 6 instead of 7? I can then express 23 as 6 times 3 plus 5, right? Where 23 is known as the dividend, 6 is known as the divisor, 3 is the quotient, and 5 is the remainder. Notice that for the first two expressions of 23, remainder is always less than divisor. So what are we trying to achieve here? In general, we can write dividend as divisor times quotient plus remainder. Basically, we are trying to express dividend in units of divisor, and whatever is left over is our remainder. As you play with more and more numbers by changing the divisor and dividend, you will see that for any given dividend and divisor, there will always be a unique quotient and unique remainder. Now this is your Euclid's division lemma. It's that simple, right? Now it might look very simple right now, but imagine a time centuries ago where there was nothing formally written about mathematics. Now Euclid formulated this at the first place so that future mathematicians and scientists could use this for other technological advancements. Remember computers? Now let's quickly formulate Euclid's division lemma in a much better way. For any given positive integers a and b, there exist unique values of q and r such that a is equal to bq plus r, where r is less than b and greater than or equal to 0. Let's seal the concept of Euclid's division lemma by looking at few more examples. Think of any two positive integers, let's say 32 and 9. By applying Euclid's division lemma, can you express 32 in units of 9? Of course you can. When you do that, you can write 32 as 9 times 3 plus 5. That is it. You have just applied Euclid's division lemma for the integers 32 and 9. Now I would like to ask you a question. Can you express 9 in units of 32? Think about it. When you think about it, you will see that you can express 9 as 32 times 0 plus 9. Now that's interesting, right? We always say 0 has no value. But see how useful 0 was here? Such a useful tool 0 is. So given any two integers, are you now confident to apply Euclid's division lemma? If yes, you can skip to the next section. If you are not confident, practice more. Look at these examples. You can solve it independently on your own. Try to solve it and look at the solution that is given in the video. If you have any doubts, please feel free to post in the doubt sections. We will be happy to help you.